Hello learners, I'm teacher 𝗢𝗲𝗍𝗄 again, and we will continue with our modules for this week, number 3, and we have modules 3D. So again, we are still on the process of simplifying rational algebraic expressions. Let's proceed to page 2. Okay. Then let's zoom this out for you to have a clearer view. Okay, the highlights of this is let's see here. The highlights are the concepts, of course, you know, the GCF, that once you have the GCF of both the numerator and the denominator, you divide it, and then to simplify those rational expressions, we have these important concepts. Let me read it out. To simplify rational algebraic expressions, we have to factor both numerator and denominator of the algebraic term by their greatest common monomial factor and prime polynomial factors. Then divide both numerator and denominator by their common GCF, or the greatest common factor. Remember that if we have this one, a, b, and c are polynomials, then c times a all over c times b is equal to ab, where b is non-zero and c is also non-zero. So this is the cancellation law. Then for number 2, we have the difference of two perfect squares. Here are the factors. You please try to remember this. A squared minus b squared is equal to quantity a minus b times quantity a plus b. And also for the sum and difference of two perfect cubes, we have it here. Now for example number 1, we have to simplify this expression, and I leave it to you in further details of this, but I have to give you a shortcut of this one. Let me have my notepad here. Let me cover the solution space. And let's try to see for a while. For example 1, the solution is obvious, so we just apply the concepts above, so I don't need to further explain it. The same is true with example 2, and let me proceed with example 3. Examples 2 and 3 are self-explanatory, but let me give you another alternative method in solving example number 3. This involves the special product on the sum of two perfect cubes. Let me cover this first. Then let's factor out. Let me use the pen first. Wait for a while. Okay. So I don't need to copy the expression, but let me read it out. 8c cubed plus 27d cubed all over 4c squared minus 6cd plus 9d squared, where c and d are non-zero. Now, let me copy first. Let's transform this in such a way that we can apply the special product. Let me write it out here. The special product, recall a cubed plus b cubed, or the sum of two perfect cubes. What are the factors of these two special products? What are the factors of this sum of two perfect cubes? So the factors are, it's given before that, this is a quantity a plus b times quantity A squared minus AB plus B squared. This is our blueprint in solving this particular example. Now, the denominator is actually in factored form or simplified form, so that is the what we call the prime polynomials, meaning there we cannot factor it out. So it's just slanting, just bear with me. So 4c squared, I'm just copying this, 6cd plus 9, I cannot name the stylus pen. Okay, anyway, okay, it's just like that. Then I don't understand. Wait, let's see. Okay, let me rewrite this as 2c times quantity cube plus, I'm just rewriting 8c cube in such a way that I can enclose it inside the cube plus 3d quantity cube. Okay. Okay, wait for a while. I think my pen is sleepy. So this should be D, not B. Okay, so let me erase that first and change it to D. So this should be D, the variable D. Okay, now in applying this special product, this is now the A, and our A is 2C. So let me write it here, 2C. And your B is 3D. Okay, that's correct. So let's apply the factoring. What are the factors of the numerator? So it's 2C because it says here A plus B. So it's 2C plus 3D. Okay. Then it says here A squared. Since our A is 2C, square this, it's 4C squared. Then we follow the minus sign, and then A times B, I mean, that is 6CD. So can you see now the pattern, or do you have some terms that we can already factor out? Anyway, so let's continue, and then here we have B squared. Our B is 3D, we square this, plus 9D squared. Okay, then we copy the denominator for c squared minus 6cd plus 9d squared. Okay, then the numerator and denominator has this prime polynomial factor. We can cancel this out, and pretty obvious, the answer is 2c plus 3d. We're done with example 3. We proceed with exercises. Number 1. Directions: read and understand each expression. Then check the column that satisfies your answer. Copy the table in your activity sheet or answer sheet. Now for number 1, s squared plus t squared all over 2. Is this factorable? Well, we notice that the numerator and denominator has no common factor, so this is already in simplified form. So we check that. We're done with 1. Number 2, we can take out 3 and 3. Then also here we can take out 3 and 3. So it's factorable. We're just instructed to check the column that satisfies the answer. So for number 3, r cubed plus 64 all over r plus 4, it's still factorable. And for number 4, it's 5k cubed. It is already in simplified form, so we can check this out. We're done with exercise number 1. We move on to exercises number 2. Directions: match column A with column B. Write only the letter of your choice in your answer sheet. Now let me answer it here. So I'll just provide a space here for 1, 2, 3, 4, and 5. Then here in column B, that's A, B, C. Let's correct this as letter D, and this is letter A. So to avoid the confusion, so just correct it in your answer sheet or in your yellow pad or intermediate pad, but not in the modules. Okay, so for number 1, what are the factors of this? So k squared minus 3 squared all over the same expression as the numerator. So we can cancel this and this one. So it ends up with 1. It's so pretty easy. So the answer is letter E, obvious. Then here in number 2, k squared minus 1. So factors are, what are the factors of this one? Well, the factors of k squared is, let me see, crush this out and put k plus 1 times k minus 1. So we can cancel this one here. So it's k minus 1 all over k cubed plus 1, which is similar or the same, exactly the same as letter A. So our answer here is letter A. For number 3, well, this is the sum of two perfect cubes. We have a special product for that. And the difference of two perfect squares. So we have a special product. So let me extend this here. Factors are k plus 2 times quantity k squared and minus, wait, erase. Need an eraser here. Okay, let's see. Continue. What are the factors? Okay, plus 2. So we have k squared minus 2k plus the square of 2, 4. Okay, I hope you guys can still follow me. This is x plus 2 times quantity x minus 2. So we can cancel this out. It is 1. So let's try to locate what is letter that corresponds to this k squared minus 2k plus 4 all over k minus 2. So this is it. Number 3 is letter D. Correct. Okay. Number 4. Well, number 4, we can rewrite this as k squared squared. So that this becomes, wait, I need a notepad for this. So let me see. Let us upload the notepad. Okay, wait. For a while, I will upload a notepad somewhere here. Okay. For number 4, so let me write number 4. So this becomes now k squared minus 1 times quantity k squared plus 1 all over the denominator. I'll just copy the denominator, k squared plus 1, and we have k minus 1. Okay, cancel this out, and take note we can still factor this. Okay, it's not yet in simplified form, so still continue k plus 1 and k minus 1. Copy the remaining expression k minus 1, and we can cancel this. So we end up with k plus 1, and it's letter B. Pretty easy. And number 5, the last for these exercises. Okay, for number 5, wait, let's just deload another notepad. We answered all 4 out of 5, so what is left here in column B is letter C. We presume that the answer is C, right? But then let us convince ourselves by solving the number 5 expression. Okay, so in number 5, we can take out the common factor in the numerator as 5. We are left with k cubed plus 1. Then in the denominator, we have 5, take that out. Then we have k squared minus 2. So we can cancel this, and we can factor out k cubed plus 1, that is k plus 1 times k squared minus k plus 1. Then, well, leave it as it is. Copy. Well, we cannot factor anyway, so we copy. This is now the answer. Actually, it's pretty obvious in letter C. We don't need to proceed. Okay, so C is the answer for number 5. We're done with exercise number 2. Okay, let us continue exercise number 3. Directions. Simplify each of the following rational algebraic expressions. Show the step-by-step process. Since we have to show the step-by-step process, I have to upload or to put here my notepad. Wait for a while. Here. And I will make this wider so we can solve as many numbers as we can. Actually, there are 4 numbers. Okay, so let's start with number 1. In the expression, we have, let's start number 1. We have here, let me rewrite number 1 in such a way that I can expand a minus b into quantity, because a minus b squared is a minus b times quantity a minus b. And I can expand this using the special product on the difference of 2 perfect squares. So the factors are a plus b, quantity, and also a minus b. So this is just easy. So we have to continue. We have here, final answer would be a minus b all over a plus b. Let's proceed with number 2. So here, let me copy 4, but let me factor out x squared minus y squared. Factors are x plus y and x minus y all over common monomial factor is 2. Then what is left is x minus y. So we can cancel this out. Then 4 and 2 is 2. So answer would be 2 times the quantity x plus y. We're done. For number 3, we have 8p cubed minus s cubed all over 4p squared minus s squared. Now let's rewrite this in such a way that we can apply the special product on the difference of two perfect cubes in the numerator and then the difference of two perfect squares in the denominator. Okay. Actually, we can rewrite as 2p cubed minus s cubed. In here we have 2p squared minus s squared. Then we proceed with factoring. Applying the special product, we have this one is 2p minus s and times quantity 2p squared is 4p squared plus 2p times s, that's 2p s plus s squared. Then factors of this is 2p minus s times quantity 2p plus s. We can cancel this out, and what is left is, wait, let me have some space for the notepad. There. Oh, wait for a while. Okay, so let's continue for a while. So we have to close this here. Then we copy 4p squared plus 2ps plus s squared all over 2p plus s. And we're done with number 3. Okay, the last, number 4. Let's rewrite this into the form hj, enclose this in q, minus kq all over hj j squared minus k squared. Then let's factor out both numerator and denominator. It's pretty easy to factor out the denominator, so let's do that first. hj plus k times hj minus k. Then we have here hj minus k. Then we have the square of hj, that is h squared j squared plus hj k plus k squared. Then we have to cancel this with this one here. So we have the final answer is let's have it here. h squared j squared plus h g k plus k squared all over h g minus k. We're done with number 4. Wait, I forgot. It should be plus, because this one cancels out to this one. Okay? Let's proceed to our numeracy skills. For the numeracy skills, or skill, then we just have to compute. And I'll just give you the hint. For the word here, it says by the bullet. Just check it with yourself. Enjoy! So this is it for Module 3D.